Yearning for just one thing more than water. Cool water. Like me, I guess he'd like to rest where there's no quest for water.
The film you're about to see is a commentary on your waterworks, past, present, and future. You will follow the growth of the waterworks from pre-treatment days, when raw river water was used, to the complex modern system of today. At the turn of the century, Cincinnati was served by waterworks which pumped raw river water to a reservoir which is now known as Eden Park. There, some of the mud was permitted to settle out of the water before it flowed to the basin of the city. Walnut Hills and Mount Auburn were served by repumping from the reservoir to the higher ground in those suburbs. The water was so full of foreign material and bacteria that it was the cause of many deaths and several epidemics. In 1897, the city fathers established a board of commissioners to study, design, and build an entirely new system. It was decided that raw water must be procured above all contamination from existing city sewers. The proposed plan also required large areas for settling basins. California, Ohio was the closest location suitable. It was not only upstream of city contamination, but it was also upstream of the polluted Little Miami River. Today, the waterworks uses modern scientific methods with continued improvements, but the basic plan and many installations remain those of a 1900 design. Let's see what they built, starting in 1898. The intake pier was put on the Kentucky side of the stream near the channel where the water was deepest. From the intake pier, the water flowed by gravity to the river pumping station through a tunnel blasted out of solid rock 60 feet beneath the bed of the river. The tunnel is 1,425 feet in length and 7 feet in diameter. On the Ohio side, the river pumping station housed the triple expansion pumps which lifted the water to the settling basins above Kellogg Avenue. These 4 pumps, each with a capacity of 30 million gallons per day, were of the piston type and were 104 feet high, the tallest pumps of their type in the world. They weighed a total of 10,500,000 pounds. These pumps were installed in the early 1900s and remained in service until 1961. In 1940, some small electric pumps were installed to take care of the peak summer loads. Speaking of peak summer loads, these little fellows are several of the many reasons why we have large summer consumption. In 1963, a second river pumping station, subsurface intake pier, and tunnel were put into service. The new station is equipped with 4 electric pumps, each with a capacity of 70 million gallons per day. These replaced the original steam pumps which had served so well. Small electric pumps in the old station now operate in conjunction with the new, larger pumps. In the new river pumping station, the pumps are located 100 feet below the surface of the ground. As the water is pumped to the settling basins, chemicals are added at this new chemical building put into service in 1962. Here, chlorine, a multi-purpose chemical, is added to the raw water. Its use at this stage is primarily one of taste and odor control. Alum and activated carbon may also be added at this point. In 1909, chlorine was used occasionally for algae control. Since 1915, it has been used continuously to control germs and bacteria as well. Process of sedimentation, coagulation, filtration, and chlorination was then considered the ultimate in the treatment of water. Today, the basic principle remains the same. These are the settling basins. You will notice that there are 2 separate basins rather than one large one. They were so designed to ensure uninterrupted service. When one basin is emptied for cleaning or repair, the other provides a steady water supply. These scenes show the cleaning of one of the basins. The depth of the accumulated silt will give you some idea of how much sediment is removed from the raw water in the first treatment. These basins are large enough to serve our system for another 10 years. located amid the greens and fairways of the California Municipal Golf Course, all on Waterworks property. The two basins have a combined capacity of 350 million gallons. Water is retained here for a period of from 1 1/2 to 3 days to permit silt to settle out prior to more advanced chemical treatment. These are the effluent tubes in the settling basin. They take the water from near the surface where it is clearest, rather than at the bottom where silt is settling out. They are bored by drums of air and chained at a fixed depth. From the settling basins, the water passes through the chemical house. The addition of each chemical has one or more objectives. Laboratory control indicates what, where, and to what extent the various treatment chemicals are used. Iron sulfate and at times aluminum sulfate are used for coagulation. Lime and soda ash alter objectionable mineral properties. Activated carbon is used for taste and odor control. When it leaves the chemical house, the water flows through the coagulating basins over the hydraulic jump. Turbulence created here mixes the chemicals throughout the water. In the coagulating basins, the fine silt, which has not been deposited in the settling basins, is formed into larger particles called floc, which are removed here. In normal operation, the coagulating basins are full of water and most working parts are hidden. This will show you what is under the water in the coagulating basins. First of two parts is the flocculator, which houses the large rotating paddle wheels that keep the floc in suspension till it is heavy enough to settle out in the second section, the clarifier. The clarifier constantly cleans the bottom of the basin by scraping the precipitated floc into the center post where it is drawn off by pumps. These basins are self-cleaning, but they are also drained and flushed each year. After the water leaves the coagulating basins, it flows to the filter house where it goes through what are known as rapid sand filters. These filters are of unusual interest. In the early 1900s, a new type of sand filter, the American or rapid sand, was conceived. Pioneering work started at Louisville Testing Station and continued at a similar Cincinnati station. On the basis of these tests, the new type filters were installed. Visitors from all over the world come to Cincinnati to see these filters. Local groups may see it all by simply calling for an appointment. Filtration is the third step in the purification process. Approximately 90% of the impurities have been removed by preceding treatment. This filter has just been washed and is being put back into service. The filter beds are composed of 21 inches of gravel and coarse sand beneath 30 inches of fine sand. In the laboratory, the chemists are constantly testing the water. Samples are taken at various stages of the treatment process. While the bacteria count is of the prime importance, the chemical analysis also records the hardness of the water, the amount of natural chlorides and fluorides in the water, and many others. In addition to these tests, samples from various points throughout the distribution system are regularly tested to determine the quality of the water at delivery points. As the water leaves the filters, it is collected in the clear wells located under the grassy plot shown here, where if needed, it can again be chlorinated. From the clear well, the water flows by gravity through a tunnel 7 feet in diameter to our original pumping station on Eastern Avenue. This tunnel has a carrying capacity of 125 million gallons per day. These scenes from inside the modernized main station show the control panel, and the electric pumps were installed in 1955. Each pump has a capacity of 30 million gallons per day. In 1952, a second tunnel and a second pumping station were added to the system. Both the tunnel and the pumping station have a capacity of 200 million gallons per day. This chimney-looking affair is the terminus of the gravity tunnel and serves as a surge chamber to control water hammer. The main station and Tennyson station are both equipped to pump to high or low distribution systems directly or indirectly, so that all areas are doubly protected in any eventuality. With this modern control panel, the operating engineers may check at a glance the pumping rates throughout most of the system. The Tennyson station has been equipped with the same type pumps as the main station. From the pumping stations, the water enters the distribution system through 3,700 miles of pipe. In the eastern hills, the pressures are dependent upon the height of the water in the Green Hills tank just off New Winton Road, the Eastern Hills tank in Kennedy Heights, and the Eastern Hills Reservoir on Winton Road. To retard the growth of algae and to eliminate airborne bacteria, the 30 million gallon Winton Road Reservoir was covered in 1957. In addition to Green Hills, Kennedy Heights, and Winton Road, a tank on Cougar Mill Road in Kenwood, and a pumping station and underground reservoir on Zinsel Avenue in Kennedy Heights were added to the Eastern Hills system. And finally, an elevated tank was constructed on Conway Road to help maintain water pressures in the Brecon and Blue Ash areas. The Western Hills system is supplied by water repumped from Central Service via the Queen City pumping station. Pressures in the Western Hills are dependent upon the height of the water in the tanks on Ferguson Road in Price Hill, the tank on Wardall Avenue in Westwood, the tank on Covedale Avenue in Delhi Hills, the tank on Kemper Road in Pleasant Run, and the tanks in Mount Airy at North Bend and Coleraine Avenues, which are so familiar to most of us. Also part of the Western Hills system is the tank on Bridgetown Road in Mack. Work was started on this improvement in 1969. Most elevated tanks on Cincinnati's system have the same general type of construction. Tanks are not added unless they are urgently needed. Once the contract is awarded, the work is completed as quickly as possible. The Mack tank was placed in service in 1970. The plan to cover all open treated water reservoirs reached another milestone when the last of the Mount Airy tanks was covered in 1963. The small tanks were covered with aluminum, but the large tanks required the use of pre-stressed concrete beams to support the concrete covers. As the distribution system expanded, a pumping station on Winton Road near Finneytown and a pumping station and underground reservoir in Summit on Glenway Avenue were added to the system to improve volume and service. In the central system, pressures are dependent upon the height of the water in the Eden Park reservoirs. In 1962, the work of covering the reservoirs was begun. Plans called for the abandoning of the East Basin and increasing the height of the West Basin by about 10 feet. This created a reservoir with a capacity of 80 million gallons and raised downtown water pressure by almost 5 pounds. A small mirror lake on top of the covered reservoir was designed to maintain the aesthetic values of the original installation. Uh-oh, one of our little friends is still at it. In 1939, the tank on 3 Mile Road and the Mount Washington tank were constructed simultaneously. The Mount Washington tank was part of the Eastern Hills system until 1951, when the Mount Washington pumping station was built. The small tank, which was originally built in Cherry Grove to supplement the water supply in that area, was replaced in 1961 by a low-level tank, along with a pumping station and an elevated tank. The result was a pressure increase of approximately 30 pounds, which enabled the waterworks to serve the high ground in Cherry Grove and the surrounding areas. In January of 1955, the city and county signed a 30-year contract which paved the way for the $30 million capital improvement program, the bulk of the improvements to be in and for the county areas. Improvements were immediately begun based upon a peak demand of 200 million gallons by 1975, more than double the average daily consumption in 1954. All these new services required additional water being made available to our Western Hills pumping station. So a 48-inch water main was laid from downtown to Spring Grove Avenue via the old rapid transit tube under Central Parkway. In the rapid transit tube on the side of the old Erie Canal, the 48-inch concrete pipe was delivered and positioned with a Ross carrier, which had to back out the entire length of the tube after each delivery. Limited space and large size of the pipe and fittings made working conditions very awkward throughout this entire project. The installation on Ridge Road also posed some unusual problems because the main was to be laid under right-of-way of the cross-county highway, which was to be supported by an overpass as it crossed Ridge Road. This meant that the main had to be laid 22 feet deep through shale. It was necessary to drill and blast this entire cut. Here the men have drilled the holes, placed the charges, and are stringing the wires preparatory to blasting. In 1963, work was begun on the well fields in the Great Miami Valley near Ross, Ohio. Plans called for several large wells, a filter plant, and a pumping station. The green lines on the map represent the large mains which will carry the water from the new works to the distribution system. This view of the map shows how most areas in Hamilton County have been aided by the expansion program. Future mains, represented by the blue lines on the map, graphically illustrate how the waterworks plans to encircle the contract area with transmission mains and serve virtually all of the county east of the Great Miami River. In order to properly serve this area, 14 repair crews are required the year-round to maintain the underground network. Because of the great differences in elevations, water pressures range from a low of 30 pounds to a high of 200 pounds. The high pressures and the continuous movement of our hillsides result in many small leaks and some broken water mains in the more than 3,700 miles of main. While the water is free, the service and purification costs money, so we must pay water bills. Before the bills can be computed and mailed, the meters must be read. These are the men who do that important job. The uniforms were designed for comfort, service, and uniformity of attire so that consumers may readily recognize a waterworks representative. These men take over 700,000 readings every year. Most of the meter readers cover their routes on foot. Automobiles are used to obtain readings in widespread areas. This is a watchdog watching the man work. This is what is known as a Ford meter box. It is a frost-proof box installed outside so that it isn't necessary for the man to enter the house to read or service the meter. These are known as remote registers. With these devices, the meter remains in the building, but the reading is obtained from outside. Administration, distribution, and commercial division offices are located at 4747 Spring Grove Avenue. Here you will find the cashier's cage where you may pay your bill in person. However, approximately 90% of the bills are paid by mail. The commercial division is the business office of the waterworks. In this division are maintained over 180,000 active accounts. Here the many clerks perform every business activity such as checking readings, ordering investigations, computing bills, and answering customers' calls, questions, and occasional complaints. Although some applications come in the mail, most are phoned. More than 100,000 requests are received each year. The waterworks makes it easy to apply for service. No signatures, guarantees, or deposits of money are required. However, the property, rather than the individual, is responsible for water bills. These are water meters, sizes 1 1/2 inch, 1 inch, 3/4 inch, and the 5/8 inch meter used in most homes. This is the IBM room. Here your bill is actually prepared. Cards are punched and bills are printed. The girls are using the machines which punch the information into a card which is later fed into the accounting machine which interprets the information and prints it on your water bill. Here the bills are being printed prior to mailing to your home or business. These are the processed cards which were originally prepared by the card punch operator. This is the sorter. This will sort out automatically any group, series, or combinations of series which might be needed for reports or statistical purposes. This employee is wiring a control panel for the accounting machine. This panel tells the machine how to proceed and exactly what functions to perform. No film in the waterworks would be complete without a tribute to its employees, 600 strong, exemplified here by a chlorinating crew of the distribution division. These men and their fellow employees assure your supply of pure water every minute of the day, hot weather or cold, fair or foul. No other industry delivers such vast tonnages into the home on a round-the-clock basis every day of the year. Neither FOB nor COD, the water is delivered PDQ at the turn of the tap. Each person's average requirements, including their share of the industrial load, would be 50 pails of water per day. Water, it is true, is free. Anyone can take it from the river, from wells, or by gathering rainwater. But imagine filling, carrying, and emptying 50 pails of water for each member of your family every day. The water you get is free. It is dependable service and the reliability of the water for which you pay. This is your waterworks, a self-sustaining public utility for which no tax funds are provided. All costs of operation are financed by revenues obtained from the sale of water. It is operated for the health, safety, and convenience of the people it serves. Remember, the bill you pay pays the way.